Welcome dear students. So let's continue with what we are doing in the last class. So in the last class we got introduced to the different properties of determinants. Okay, same things we are going to apply in today's class also. Alright, so question says, show that one root of this equation, this is equals to 0, is this much. Now solution root means what? Means the value of the variable, and here the variable is x and the rest are just the constants. Okay, so let's see how to solve this equation using properties. Okay, so fine. So given is, so this one, right? So given is x plus a b c, x plus c b a, and we have c a x plus b equals to 0. So this determinant is given to be 0. Okay, so what am I going to do is, first and foremost I'll write this. See, this is a column, right? This is row. Whichever way you want to work, you can work. Okay, so here what am I going to do is, I'm going to write row 1 as row 1 plus row 2 plus row 3. Now this is also allowed. Okay, so this is also allowed in case of determinant. You can add up all the rows or all the columns. So basically you are changing only row 1. Remember, you are not changing row 2 and row 3. So let me keep it as it is. So you get row 2 becomes, see here carefully, row 2 becomes b x plus c a, row 3 is c a x plus b. No change. There is no change in the row 2 and row 3. The only change that you are making is in the row 1, and row 1 is row 1 plus row 2 plus row 3. So when you add row 1, row 2, row 3, you get x plus a plus b plus c, x plus a plus b plus c, right? So you get x plus a plus, okay, so make your determinant a bigger one, so I don't have space, so let me write this way, plus c. Okay, so this is my first element. Next, add this, this and this. Won't you get the same thing? X plus a plus b plus c. Yes, so you write same thing here, x plus a plus b plus c. Same thing happens with this also. C plus a plus x plus b is nothing but x plus a plus b plus c. Okay, and we have equals to 0 out here. Alright, now see, the first row is same, right? All the elements of first row are same, so let me take it outside. Alright, so if I do that, you get, so let me write it here only. So you get x plus a plus b plus c. So this is out. So in the determinant you are left with, so this is gone, means there is 1 1 1. So 1 1 and 1 is left, is equal to 0. Remember that. Okay, so we have b x plus c a. Next we have c a x plus b, c a x plus b. Okay, so this is what we get. Now see, when you solve this, this cannot be equals to 0. Okay, so because if you know, in the earlier exercises we showed that this kind of thing turns out to be 0. Okay, so you know the value of determinant becomes 0 if any two rows or any two columns are in proportion, isn't it? But such case won't happen here. So in this case what am I going to do is, next I'll make it 0 and 0. Remember in the first class, if you have two zeros here, then the calculation of 3 cross 3 determinant becomes very easy, right? Can I make it 0? Yes. Can I make it 0? Yes, I can make them 0. So this is my column 2, this is my column 3, right? So let me write column 2 as, so I'm making column 2 as column 2 minus column 1, and similarly I'm changing column 3, so column 3 minus column 1. So column 3 is column 3 minus column 1. So if I do this operation, let's see what do we get. So this is always there. So this is your x plus a plus b plus c. This is always there. Okay. So you're not changing this column 1. So column 1 will remain as it is. So 1 b c. It is kept as it is. 1 minus 1, c2 minus c1. 1 minus 1 is 0. Okay. X plus c minus b, right? So x plus c minus b is there. Okay. And we have next a minus c, right? So we have a minus c. Okay. So similarly, c3 minus c1 gives you 0, right? Okay. So we have a minus b, and at last we have x plus b minus c. So x plus b minus c, and this will be equals to 0. Now the evaluation is very easy, right? So you just need to evaluate this one. So we have x plus a plus b plus c. Okay. Now into just write 1, and we have just determinant of this. Okay. No need to evaluate for zeros. So you get x plus c minus b, a minus b, a minus c, x plus b minus c is equals to 0, right? Now, do we have a role of 1 here? No. 1 into anything will remain as it is. Okay. So that means either this has to be 0 or this has to be 0. Okay. So if you want to simplify this determinant, that also can be done. Remember, this into this minus this into this. Okay. From there also you can find the value of x. But from here, okay. So let me say either x plus a plus b plus c is 0, or we have this determinant equals to 0. Okay. So evaluate this by yourself. I'm just interested in this part because this gives me x equals to minus a plus b plus c, and that's what I'm interested in. So question says one of the root or one of the solution of this equation is minus a plus b plus c, and that's what I have shown here. Okay. So you may pause the video and note down your solution. Next we have without expanding, prove this. So in such kind of questions, we'll first deal with the first part. Second part we'll just omit. Okay. So first let's see this one. So given is we have one. We write. So let's write. We have a b c x y z p q r. Now, one of the properties is that if we interchange two rows or two columns, what will happen? You get that the sign of the determinant changes, isn't it? Okay, so that's what I am going to do. So, in this case, you see this xyz got shifted to this one, isn't it? Right? So, let's interchange these two. Okay, so I am just changing, I'm just interchanging these two, that is row 1 and row 2. Okay, so change row 1 and row 2. Let's see what do we get. So in that case this becomes equals to negative sign, you know that, right? So xyz. Okay, so ABC comes in the second row and we have PQR. Okay, now so XYZ went up. Okay, and what happened? We got ABC in the middle, but I want ABC down, isn't it? So that means I have to shift this here. So that means I have to shift or exchange row 2 and row 3, isn't it? So row 2 and row 3, if they are exchanged, let's see what it becomes. So sign will reverse, isn't it? So this is minus, so it reverses and becomes plus. So that's why it becomes, so XYZ, I am not changing first row, so XYZ remain as it is. So you know PQR comes to the second row, PQR, and this ABC goes down, right? ABC goes down. That's what I want, isn't it? Right? So this is my first part. Now second part is, see here carefully. So you want to see x, y, z is becoming column, isn't it? Yes. So basically what they have done is, first they have to see x, y, z is in the row, but here x, y, z is in the column. So basically they have transposed here, isn't it? Yes. Now, so let's see what happens. Now, you know, one of the properties says that so first let me write this only. Now we have you know, this is the given thing, so let me first write this one only. A, B, C, X, Y, Z, and we have P, Q, R. Okay, so let's find the transpose of this. Okay, so the row becomes column here, isn't it? Okay, now what shall I do? Okay, so instead of taking this, let's take this only, because this first row becomes my first column. Okay, so I'm sorry with this. So let me take the second determinant only. Okay, so second determinant contains x, y, z, p, q, r, a, b, c. So if you find the transpose, what happens is this first row becomes first column, x, y, z. This becomes p, q, r, and next is a, b, c. A, b, c. Okay, so these two determinants will be same. Why? Because you know that this property is valid. Yes, so using this property I can write this. Okay, I'm sorry, there's a mistake in the question. So this is Q and this is your P. All right, that's what is there in the book. All right, so now see, what I want is, I want Y, B, Q, right? Y, B, Q. So that means I need to interchange column 2 and column 3, right? Let's do that. Okay, so if I do that, okay, so interchanging column 2 and column 3 gives you, so when you interchange, what happens? You get, the sign will get changed. So x, y, z is already there. Next is, we have this ABC comes here, ABC, and you get PQR. So this is my PQR. Okay, now let's see what's wrong here. So what I need to do here is, I want y here and x in the middle. Z, C, R, it's in the correct position. So let's exchange these two rows. Okay, so row 1 and row 2, when they are, when they are exchanged, you get, sign will get reversed. So that's why this will be equals to ultimately, so y, b, q. So this becomes a, x, a, p, x, a, p, and the last one is z, c, r. So that's what I want here. Yes, so you may pause the video and note down your solution. So next we have, without expanding, we need to prove this. Let's see how to do this. Now we have been given the determinant a square bc, b square ca, c square ab. So this is the given determinant. Now if you see here, from this, let's compare this with this. A square this. Now here a square a cube is there. So basically we can multiply this by a, because you get a square, you get a cube here. So let's first multiply first row with a. Okay, so if I multiply with a, so see here carefully. So if I multiply this determinant with a, the first row with a, then I have to balance this, no? So for balancing, I'll put a in the denominator. Okay, so if you multiply this with a, that multiplication is extra, no? So in order to balance that, I'll put a here in the denominator. So when you multiply, you get, let's say, what do you get? So you get a square, a cube, and this becomes abc, right? So this is about the first row. Now what about second row? In second row we have b and b square. Here we have b square and b cube. So let's multiply second row by b. Okay, so if I multiply with b, I need to balance, no? So for that, I need to divide by b. Okay, so after multiplying with b, let's see what happens. So it becomes b squared b cube. This becomes b into ca is abc. Okay, now ultimately the last one is also similar. So we have c and c squared. There we have c squared and c cube. So we will multiply this by c. So in order to balance, we will put c here. Okay, so basically we will do this part, okay, or this operation. So we have c squared c cube abc. Now observe column number 3. abc is common, isn't it? So that's why this can be written as, let me take out this abc. So abc is taken outside, so we already have divided by abc. So in that case, we are left with a square a cube 1. Okay, so 1 is also coming. Now next is b square b cube 1. Next is c square c cube 1. Okay, now these two gets cancelled, so this is vanished, this is there. So will you be able to arrive at this from this? Just you have to interchange the columns. Okay, so you have to do 2 steps, then you will get your final answer. Okay, so if you are not able to do this, you can make use of the earlier problem. Okay, so you may pause the video and complete the sum by yourself. So using the properties of determinants, you need to prove that this will be equals to 0, where alpha, beta and gamma are in AP. Now, first and foremost, let's understand what is the meaning of A, B and C being in AP. It means that B minus A is equals to C minus B. So we call this difference as common difference, isn't it? So bring this B out here, take this A over there, you get 2B is equals to A plus C. So basically, if A, B and C are in AP, it means that 2B is equals to A plus C. Similarly, if alpha, beta and gamma are in AP, it means that 2 beta is nothing but alpha plus gamma. Okay, so given alpha, beta and gamma are in AP. So I told you this means that 2 gamma must be equal, 2 beta must be equals to alpha plus gamma, right? So this is the thing that we have with us. Okay, now let's make use of this. Now here you see in the second row we have beta, isn't it? So we have to prove that this is equals to 0. Remember, we are not solving or we are not finding the value of x. Okay, so let's take the left hand side here. Okay, so left hand side contains x minus 3, x minus 4, x minus alpha, we have x minus 2, x minus 3, x minus beta. So we have x minus 1, x minus 2, x minus gamma. Now let me do one operation here. The operation that I am going to do here is, let me write R1 as R1 plus R3. Okay, so if I do that, let's see how much do we get. Alright, so we get equals to, so remember you are adding row 1 and row 3. Okay, so if you add this, x plus x is 2x. So minus 3 minus 1 is minus 4. Alright, similarly 2x minus 4 minus 2 is minus 6. So this becomes 2x minus alpha plus gamma. Okay, right? Okay, so we have, next is, so you are not changing anything. So let me do some manipulation out here, because here we have beta, isn't it? I'll make it 2 beta. For that, I need to multiply the second row by 2. So when you multiply by 2, we have to balance by this particular factor here. Okay, so let's multiply this. So you get 2x minus 4. Yes, This is 2x minus 6. We are multiplying with 2, remember. So this becomes 2x minus 2 beta, right? So the last one will remain as it is. So x minus 1, x minus 2, x minus gamma. Now, you know the value of alpha plus gamma is 2 beta. So in place of this, I am going to write 2 beta. Okay. So this is equal to, so 1 by 2, we have 2x minus 4, 2x minus 4, 2x minus 6. So this becomes 2x minus 2 beta. Yes or no? Okay. So similarly, we have 2x minus 4, 2x minus 6, and we have 2x minus 2 beta, and the last one is x minus 1, x minus 2, x minus gamma. Now observe row 1 and row 2. These two, are they same or are they identical? Yes. So since row 1 and row 2 are identical, the value of this determinant becomes 0. So half into 0 becomes 0. Okay. So you mentioned since row 1 and row 2 are identical, so that's why the value of this determinant becomes 0. Okay. So ultimately we wanted to show that this is equals to 0, isn't it? So that's why this is equals to my right hand side. Okay. Pause the video and note down your solution. So let's have a look at the last question for the day, and in the next class also we are going to continue with the same thing, that is the properties of determinants. Okay, so for doing this kind of sum, there is a special result, or rather you can call it a formula. So determinant of AB will always be equals to determinant of A into determinant of B. So you need to know this particular formula in order to solve this. Okay, so let's first find, since we are doing determinant, let's first find what is determinant of A. Okay, so determinant of A is nothing but, so determinant of 5 alpha, alpha 0, alpha 5 alpha 0 0 5. Now I told you, whenever you have 0 0 out here or here, then your work is simple. Okay, so you just need to evaluate this. See here carefully. So 5 into, so this becomes alpha 5 alpha 0 5. Okay, right? Now next, 0 and 0, don't include them. So we have 5 into, so let's see how much this alpha into 5 is 5 alpha, minus 0 into 5 alpha is 0. So how much is this? This is 25 alpha. So we got the value of determinant of A. Okay. Now given is this determinant of A square is 25. So can I write this as A into A? Yes. Okay, so this is this much. Now using that particular formula, can I write this as determinant of A into determinant of A? So this is 25. Okay. Now see, what is determinant of A? It is 25 alpha. So that's why this becomes 25 alpha into this is 25 alpha. So this is 25. Okay. So we have alpha into alpha, alpha is square. So 25 is there. So bring both 25 to the denominator. So one of them gets cancelled. So alpha square is 1 by 25. So therefore the value of alpha, if you find the square root on both sides, it becomes plus minus 1 by 5. Okay, so this is my answer for this particular question. Okay, so you may pause the video and note down your solution. So with this we close for the day. Thank you very much.